Preparation of aldehydes and the ketones. Now we will discuss what are the different methods of preparing aldehydes and the ketones. Aldehydes and ketones can be prepared from the nitriles as well. Nitriles, the general formula is RCN. Alright. Here we have a carbon nitrogen triple bond, and if you reduce this compound, the nitriles here, for the reduction we can use the stannous chloride and the HCl. Okay, this is a very good reducing agent, a very strong reducing agent. It can reduce this alkyl cyanide, and one of the hydrogen, this triple bond, the carbon nitrogen triple bond which is there, actually one of the pi bond will break and each carbon gets, this carbon gets one hydrogen, nitrogen gets one hydrogen, so you get actually an imine here, right? You get an imine. So after you get an imine, now you can further hydrolyze it, right? You can react with the water in the acidic medium, and then what will happen, this nitrogen will be completely lost from the molecule and you get a carbon double bond oxygen, and this nitrogen will be lost as ammonia. Alright, this will be lost as ammonia. So this reaction is called as a Stephan reaction, right? Stephan reaction. So what we do in this reaction, you can first reduce the nitriles. So after the reduction, it is followed by the hydrolysis. So that means alkyl cyanides, when you react with the SnCl2 and HCl, first thing, and the second thing is that after that you do some hydrolysis. So what you get, this carbon, it changes into the C double bond OH, and whatever is the substitution here, you keep it there. So you get an aldehyde from the nitriles. So this is a two-step process and you get only aldehydes. You cannot get the ketone here, right? Remember, you cannot get the ketone. So that means this Stephan reaction, it is used to only prepare aldehydes. You cannot get the ketones from this one. Let's take a few more examples here. You got the benzene ring attached with the cyanide. So first you do the reduction, stannous chloride and HCl, and followed by the hydrolysis. What you will get, again this nitrogen will be lost as ammonia, and you put a carbon oxygen double bond and a hydrogen with this one, right? That is the net reaction, correct? The overall, the net reaction is that you put a carbon with a double bond and one hydrogen with the carbon, right? So that means you get a benzene ring here in this case, and the carbon will be having a double bond and a hydrogen atom. All right. Here in this case again, first we are reducing it with stannous chloride and HCl, and then we are doing the hydrolysis. The overall, this reaction will be that you break this carbon nitrogen triple bond and put a carbon with a double bond O and a hydrogen, and since there is a methyl group here, so you can attach the methyl here. So this is the overall reaction. So you get an aldehyde from this one, from the nitriles, by treating with the stannous chloride and HCl and followed by the hydrolysis. We also get aldehydes and the ketones from nitriles and the Grignard's reagent. If you combine the nitriles and the Grignard's reagent, if you react the nitriles with the Grignard's reagent, then you will get aldehydes and the ketones. Again, this is a two-step process, right? This is a two-step process. So what we do actually here in this case, we take a nitrile. Let me take RC triple bond N. So this is our nitrile, and if you react with the Grignard reagent, this is RMGX. This is this X can be any halogen, it can be bromine, fluorine. We know this Grignard reagent is R negative. This is our nucleophile, and magnesium has got a positive charge. And what happens first when you react to the Grignard reagent with the nitrile? First there will be the addition reaction, right? This Grignard reagent will add across a pi, this carbon nitrogen pi bond, right? So the pi bond will break, and one of the alkyl group here, it will go here, and the magnesium will go with the nitrogen, right? It will go and attack here. So the triple bond will break into double bond. Now you got a molecule like this, RC double bond N, and you got one more R group. Let's see, this is R dash here, right? R prime here. This one, two different distinction between the two alkyl groups. One alkyl group is from the nitriles, and this R is from the Grignard reagent. And this nitrogen will be over here. This magnesium will be over here, MgX. This is again our addition product, right? This is our addition product. When you react the Grignard reagent with the nitriles, this is what you get. And now after that we further hydrolyze it. You break the molecule by adding water. So when you hydrolyze it, this carbon nitrogen bond breaks completely. Alright, carbon nitrogen bond breaks and you get a carbon, this particular carbon having a double bond oxygen, right? Okay, this carbon will be having a double bond oxygen, so you get R prime C double bond O R. Now you got a ketone. Here in this case you got a ketone, plus what you get, the nitrogen is lost as ammonia, and this magnesium will be attached with the halogen and a hydroxide group from the water when you do the hydrolysis. Alright, because here in the hydrolysis we are adding the hydroxide and the H, correct? Okay, so you get these two products here, ketones, and you get ammonia, nitrogen loss is ammonia, and this is the MgXOH. Let's take some cases, some examples in this case. Suppose here this is our HCN. You react first with the Grignard reagent. This one, what you will expect? You expect a product like this. You got a carbon double bonded with the nitrogen. Now it has got a hydrogen, and this cyclic ring will be attached with the carbon, because this is our R group here, isn't it? We learned that RMgX, R it goes to the carbon and MgX it attaches with the nitrogen, so you get MgX here, and then this is our addition product. So after that, when you hydrolyze it, you do the hydrolysis here, what will happen? This bond will break completely. You get a carbon double bond O and a H and a cyclopropane ring here, and you get ammonia, and you also get the magnesium with the halogen, and here will be the hydroxide. The halogen, here we have Br, so you can see it is Br here, it will be here the Br, bromine. Alright, this is the overall addition, right? You get an aldehyde here in this case. Now in this case here, in the second example here again, you got a CH3CN. So the overall addition is that you have to remove the nitrogen and you have to attach the alkyl group. Okay, this is our cyclohexane is our alkyl group. So this is the group that you will attach with the carbon, and the carbon will be having a oxygen. That is the overall addition, right? That is the overall addition that occurs here in these two steps. You break the nitrogen carbon nitrogen bond, nitrogen losses ammonia, you put a double bond oxygen and attach a one alkyl group from the Grignard reagent. So if you repeat the same things here, what you will expect, you will get a CH3C double bond oxygen and a one cyclohexane ring, right? Because that is the alkyl group here in the Grignard reagent. And what else you get? You get the ammonia here, and you get a magnesium with the bromine, and you get a hydroxide there. Alright, this is how you get aldehydes and the ketones from the reaction of nitriles with the Grignard reagent.